Hi everyone, I am your classmate, aka your lecturer for today's discussion. I am Marcelo Torcino Cameras, and welcome to the Organic Chemistry, where learning is fun and exciting, also discovering something new are amazing. For today's discussion, we have the structure and bonding, particularly Lewis structure in organic chemistry. For today's objective, we have the students are expected to understand the Lewis structures and know how to write it properly, familiarize the different structures, determine the carbon bonds in the other bonds, know the valence electrons and where it is to be found, and also the students are expected to find out the correct placement of the atoms, and also, or lastly, the students are expected to differentiate the structures. By the way, what is organic chemistry? Organic chemistry is the study of molecules that had carbon atoms on it. And what are we waiting for? Let's go to our first slide. What is Lewis structure? By the way, we have the definition here of Lewis structure. It says that Gilbert and Lewis introduced the Lewis structure in his 1916 essay, The Atom and the Molecule, and it was named after him. Lewis structure add lines between the atoms to indicate shared pairs in a chemical bond, extending the notion of the electron dot diagram. And we have the second definition here. A Lewis structure is a molecule structural depiction in which dots indicate electrons' location surrounding the atoms, and lines or dot pairs represent covalent connections. The objective of creating a Lewis dot structure is to aid detect chemical bond formation by identifying the electrons, pairs, and molecules. And also, Lewis structure is simplified representation of a molecule valence shell. In addition, a Lewis structure is based on the concept of octet rule, in which an atom shared electrons to each atom. It has 8 electrons in outer shell. Say for example, an oxygen has 6 electrons in its outer shell. Lewis structure, these 6 dots are arranged that an atom has 2 lone pairs and 2 single electrons. The 2 pairs would be opposite each other around the O symbol of the oxygen, and the 2 single electrons would be on the other sides of the atom opposite to each other. Why Lewis structure is important, or why do we need to study Lewis structure? Well, it's stated here that Lewis structure is basically a graphic representation of the electron distribution around an atom. The major reason why learning Lewis dot structure is important is that it helps in predicting the number of and type of bonds which can be formed around an atom. It also helps in predicting the geometry of the molecules. Knowing the Lewis structure allow you to know how it will bounce and how many bonds will form. This knowledge eventually can allow us to understand the shape of molecule and their chemical properties. Here is the simple view on this important topic. In Lewis structure, we show each covalent bond as 2 dots which represent a pair of electrons. Say for example, in this presentation, you can see the different elements. We can see here the carbon, the bromine, and the oxygen. we already know that the carbon has already 4 valence electron. It shows here that the carbons already bond to the hydrogen. When you are seeing when you are encountered 2 dots, that means they are already paired, or they are already bonded. They are equal to the one line. It also means that they are bonded already. We can see here the bromine. The bromine here has 7 valence electrons and 1 other valence electrons from the bromine, and 1 other separate valence electron from the bromine also are bound together. The presentation shows that the 2 dot, they are using 2 dot and 1 line. Also, that means they are bonded already. In this the third example, we are seeing the oxygen bond to the hydrogen, and the other side the oxygen bond with the hydrogen. The oxygen has the 6 valence electron and it bonds already. So the bonds can be represented either with line or pair of electrons, which is by the use of dots. As a reminder, valence electrons are the ones in the outermost energy level. So let us proceed to the drawing Lewis structure. In short, these are the steps you need to follow for drawing a Lewis structure. It has 5 steps. First steps, you need to write the correct skeletal structure for the molecule, and it has or be reminded that hydrogen atoms are always terminal, which means only 1 bond, and also put more electronegative elements in the terminal positions. The second steps, sum the valence electrons from all the atoms. You need to add all of those. And the third steps, use a pair of electrons to form a bond between each pair of bond atoms. You need the 1 electrons from the other atom and 1 electrons to other atom to be bonded all together, to be paired. And the fourth step, add the remaining electrons to satisfy the octet. When we are talking about octet, it derives from its root words, oct. When we are talking about oct, it is octagon. It has the 8 side. Octet for more electronegative atom first. In this step 4, you need to add all of those electrons that remain. And the fifth step, or the last step in drawing Lewis structure, if any atoms lack an octet, make a double or triple bond to give them an octet. So these 5 steps are very clear and very understandable, so that it is easy for you to follow. Reminder that the valence electron correspond to the group number of the elements. Let's go over in a more detail by drawing Lewis structure of H and Cl, or hydrogen and chlorine. The first thing in drawing a Lewis structure is to place the atoms in the correct location, and since we only have 2 atoms here, we can only place them next to each other. As you see here, I write the H, then Cl, and in general as well, remember to always put the hydrogen on the periphery, because it has 1 electron and can only make 1 bond. You can see that bonding patterns of the most common elements in organic chemistry in the valency and formal charges post. Next, sum the valence electrons, 1 from the H or group 1 and 7 from the Cl or group 7. Therefore, we have 8 valence electron. For you to found or to determine the number of valence electron, you need a periodic table of elements, and those group or the family is the number of group and family of the elements are the number of your valence electrons. Out of these 8, 2 electrons must be used to make a bond between the atoms. As you can see here, we have the 2 elements, hydrogen and chlorine. To make a bond, we need to pair the 2 electrons, 1 from the chlorine and 1 from the hydrogen. This process make a bond. As you can see, the product here, we have the hydrogen, then the 2 dots, then chlorine. So the meaning of this is the hydrogen and chlorine are bound together. The next one, this leaves us with 6 electrons because we are already paired the 1 electrons from the hydrogen and 1 electrons from the chlorine. So they are merged. So we have the remaining 6 electrons. Remember to put the remaining electrons on the more electronegative atom first and then the other if more electrons are still available. So the 6 electrons go to the chlorine. As you can see here, we have 2 red dots, and this represents the bonding electrons. And we have the blue dots here. This one is called non-bonding electrons or lone pairs of electrons. These electrons are called non-bonding electrons or lone pairs of electrons. And instead of saying the chlorine has 6 electrons, even though it is not wrong to say so, we normally count them in pairs and say that the chlorine has 3 lone pairs of electrons. Finally, check to make sure that the following elements obey the octet rule, which applies to CNOF and all the other halogens. The octet rule states that some elements tend to have 8 electrons around them, whether by a bonding pattern or in their ionic form. The bonding shared electrons are included in the electron count of each element. You can see that the red are the bonding electrons and the blue are the non-bonding electrons. We have 8 non-bonding electrons and we have 2 bonding electrons. Hydrogen does not follow the octet rule since it has 1 electron and can only form 1 bond, which is referred to as the duet rule. In Lewis structure, the bonds can be shown either by dots or lines. Say for example, the previous structure can also be shown as follows. As you can see here, we have the triple bond, we have the line. They are showing us the dot bond and line bond, and also it has the triple bond. Okay, let's proceed to the double and triple bonds in Lewis structures. Let's now draw Lewis structure of carbon dioxide or CO2. As always, the first step is to place the atom correctly. Oxygen, being more electronegative, goes on the periphery. As you can see, OCO. For the valence electrons, we have 4 from the carbon and 2. And so 2 times 6 equals 12 from 2 oxygens, giving 16 valence electrons in total. As you can see there, as you can see here, the computation of the total valence electrons that we have. Okay, let's have this one. One bond between the carbon, and each oxygen takes 4 electrons and we have 12 electrons left. And then place 6 on each carbon and check for the octet. When we are talking about octets, it is consist of 8 bits, or in chemistry, the octet are the arrangement of 8 electrons in the outer electron shells of the noble gas atoms. It's stated here that the oxygen have 8 electrons, however the carbon has only 4, and in these cases you need to move one of the lone pairs from the element that has an octet to the element lacking an octet to make another bond. As you can see here, we move one of the lone pairs, we move the oxygen, and the next one, the same is done for the another carbon since it still lacks an octet. We just do the similar things that we have done earlier. At this point, all of the atom have 8 electrons. Notice that there are 4 electrons between the carbon in each oxygen, which means they make 2 double bonds. As you can see here, we have the 2 double bonds from the oxygen to carbon and carbon to the oxygen. Okay, let's proceed to the Lewis structure of organic molecule. Let's see how to work around a problem with a larger organic molecule where the placement of atoms is given and you need to add the bonds and any possible lone pairs. For example, draw an acceptable Lewis structure for the following compound. And then the next one, we need to count the total number of valence electrons. So here we have the 30 valence electrons, and make a bond between each neighboring atom. As you can see here, they are bound to each other. Then count the remaining electron and place them on the atoms in the order of their electronegativity. You need to place their in order of their electronegativity. For example, we have to place the 6 electrons on oxygen and 2 electrons on nitrogen. And we need to identify the atoms lacking octet. Here we have the carbon, it lacks an octet. Move one lone pair from the oxygen to make a double bond. As you see here, the oxygen was moved and caused the double bond to the carbon, and all have octet, and this gives us the Lewis structure for this organic molecule. Now let's pay attention to something more interesting here. You may wonder why we did not move the lone pair from the nitrogen instead of the oxygen in the following way. So that is a good question, and the answer is that it can be done either way. For example, we could have moved either of these lone pairs. The next one, A and B are both correct Lewis structure of this molecule and are called resonance structures. Resonance structures can be interconverted to one another by moving some of the electrons. The next one, the arrows that show the movement of electrons in resonance forms are called curved arrows. As you see on the presentation, notice also that the oxygen and the nitrogen are charged in the resonance form B. These are called formal charges. Sorry to bother you all. hopefully you'll learn something from me. Thank you and God bless.